Next up, we have the winners of a hackathon that was put on by NTT Research. This hackathon was different, and it actually took a novel encryption idea created by NTT Research Syslab director Brent Waters back in 2005 and developed prototypes for productization. I would like to, if we can, welcome up to our stage Jean-Philippe Cabay and Pascal Mathis from NTT Belgium. Gentlemen, please come up to the stage.
Okay. My name is Pascal, and here is my colleague Jean-Philippe. And thank you all for being here, and a special thanks to the judges of the ABE hackathon, which took place last September. And I have seen many of the judges in the room, and their great wisdom gave us the amazing opportunity to travel from Brussels, NTT Belgium, to San Francisco to meet you all, and to present you a way of using a crypto system based on the attribute on the users, and we use it to manage the privacy in images. Okay.
So, back in September of last year, we were brainstorming to get an idea of what we would present during the hackathon, and we remembered a news that was happening at the time, where in a metro station in Brussels, a man pushed someone on the tracks of the metro. Hopefully, nobody was hurt, but the story made a lot of noise because the video footage of the surveillance camera leaked onto the internet with the faces of everybody there completely visible. This story made us think about who really has access to those cameras. For this news, it was actually an employee that was working in the metro station that leaked the footage. And so with more and more cameras everywhere, we really have to think who can have access to this data. And this is what we will present to you today. So how we could use ABE to secure information inside of images. So now, Pascal will present to you ABE.
First, I would like to quickly get started with a short presentation of ABE. In classical encryption, when a private document needs to be sent, the person who needs this document sends his public key to the sender. This public key travels across the network, so it is not considered as safe. We can assume that the key can be compromised. But it doesn't matter because this key is only used for encryption, and it's not possible to decrypt with this key. So the document is encrypted with the key that gives a ciphertext, and the ciphertext can be put in a database, and then a receiver can use his secret key and decrypt the documents. That's classical encryption, and actually that is what you use almost every day. Instead of the man on the left-hand side, you have a web server when you can buy things, and instead of the woman on the right-hand side, there is your favorite web browser. And each time you have an HTTPS connection, it works. It starts like this. With ABE, it's pretty much the same idea. There is a public key to encrypt, but next the things are a bit different. So the sender got the public key. The sender encrypts the document, but now there is an extra parameter, which is a condition to decrypt. Here, the condition expresses that if you are a doctor or a nurse and you belong to the neurology department, then you are allowed to decrypt the document. Then the ciphertext is put in a database, and imagine now on the left-hand side we have users that want to access to the document. So a doctor from neurology authenticates in a system, he gets his attributes. He cannot set the attribute by himself. And with these attributes are then used to get a secret key which allows him to decrypt the document. And that's the same for a nurse in neurology who gets a different key. But for a doctor in cardiology, here, she can ask for a key, gets one, but the decryption will fail with this key because it does not match the condition. And this is a way of using ABE, attribute-based encryption, a way that we use in our ID. So we have an encryption key, multiple, I would say, secret keys, multiple decryption key, and the usual application for that or data in database when you can encrypt rows or columns that contain sensitive data, and they can be encrypted according to some policies. And another common application, it's in IoT, where sensors provide information that can be that are encrypted. But now let's see how we can use ABE, but in images.
Yeah. So before going to videos, let's start by images. So, for example, in this image of taken in front of the headquarters of entity research, we can see several things in the image that could be thought of as sensitive information. So, for example, you could have the face, the license plates, the faces, and also maybe textual information. But that's not all. Usually, when a picture is taken, it is associated with some metadata, which can tell you a lot about where the photograph was taken and when. So now that we have a rough idea of what could represent sensitive information in an image, how do we do to identify the areas in the image? To do that, we can train an AI model to detect and classify the different areas in the image, and then use attribute-based encryption to encrypt using a different policy every areas depending on the content of them. So the faces will be encrypted differently than the car plates, for example. So then we have our encrypted image, and we want to decrypt it. So, for example, a first user could have attributes that let him reveal nothing in the image. He sees only the anonymized image. A second one could only see the faces. A third one could see everything except the faces. And maybe a fourth user could see all the information in the image, but not the metadata. With all of that, we can go from images to videos.
Yes, with videos, there is a small adaptation to make, because asymmetric keys, it's when you have a public key and a secret or private key. With these keys, you can encrypt very quickly all what you need to encrypt. But for images, it's not quick enough. So what we use is symmetric key. Symmetric key, it's when you have one key, the same key to encrypt and to decrypt. And so we use symmetric key for each class. So for instance, for license plates, we have a symmetric key. For person, we have a symmetric key. And all the symmetric key are encoded with ABE. So it's a box in a box. But it's just technical detail. It does not change the main idea. When we need to access to some information, we need to the user need to fulfill the condition used for the encryption. And now I can show you a short demo of what we have implemented. So this is a video we shot in San Francisco, 2 blocks away from here. And So our AI detected some cars, license plates, person, and so on, and we blurred this part, and the unblurred parts, the unblurred sub-images, were encrypted in the way we just mentioned. The encryption was made with some policies because ABE worked with conditions. And for instance, if you look at the first line, if the AI model detects a head, then just the sub-image of the head is encrypted with this policy. And if you want to see the head, you must be a police officer, you must belong to an identity department, and you must have a rank higher than 2. And so this is the video. All the private information are blurred. But here I can set some attributes just for the purpose of the demo. I don't have to authenticate. I just can put the attribute like this. So I just use the attribute officer. And with this attribute, I can reveal all the cars, but not the license plates, neither the persons. I change now. Now I'm an assistant with a rank equal to 4, and I can see the license plate. This one and this one, but a very tiny one. Now if I want to see the person, I can use other attributes. Okay, like this. And at the end, stronger attributes that can reveal, so we can enjoy the constant smiley face of Jean-Philippe. Okay. So thank you. Thank you so much. Another example now. We had a talk with Christian from Entity Research, and we have a talk about this idea of encrypting videos like this, and he came up with a lot of possible applications, and one of them caught our attention. And it is the ring bell cameras. And I found this video on YouTube. I don't have a ring bell camera at home. So the idea is that if someone rings at your door, you want to see him, but you don't want to see the background, or you don't want, everybody wants to see the background, but it could be not allowed. So just to clear a bit the image, if I take this attribute, I see that there is some car, and we can imagine there is a person here between the car. And so we introduce kind of context in the encryption, and like a plugin. And the plugin here is a doorbell camera, and this plugin makes that the encryption, the encoding, of the video work as usual, but when a person is very close to the camera, so you can see it. So I just go back to the original image, for instance, by putting some random attributes that can decrypt nothing. And now here is how it works. So a person is coming, and suddenly is not encrypted because of the plugin that works like this. And so the owner of the house can see who is coming, but to see what happens in the background, it's only possible for certified persons. So with some attributes. Okay, that's it for the demo. We can go back to the... Thank you.
Now, until now, we have talked a lot about security footage, but actually the application of this technology could be go far beyond. A first example would be to help organizations to comply with privacy regulation. For example, GDPR in Europe, where there is a high demand for such technology, because if an organization wants to install a camera and do some analytics on the video stream, they need to be certain that all the personal data of people going through is secure. And with this technology, it is possible. But also in the medical field. For example, CT scans or MRI scans contain a lot of sensible information about a patient's health. There's also the metadata associated to those images that can tell you who it is, its age, etc. So you really want to control the access to that information to only the appropriate persons. But you can also go further. Imagine that you have this database. You could do some anonymized AI training where a data scientist could get only the images and train a model on them to detect anomalies in the CT scans without compromising the privacy. But also from the bank side, in governmental organization and other organization, there's still a lot of scanned document use, which can also contain some sensible information, such as social security number or financial data, which could be also secured using this technology. But we want to only talk about possible projects. Actually, we have already multiple projects in the pipeline and a high demand for this technology. So for the moment, we are working currently on a monitoring of people flow in hospitals, so such that doctors can see which patients are waiting and the number of patients waiting, but not someone else in the hospital. Surveillance of manufacturing plants to be able to detect if there is no one that climbs fences to go on a manufacturing site, but also a project for the smart city of Brussels, where they were having problems to install smart cameras to be compliant with GDPR, and really using ABE on videos and images solves the problem. So that's it for our presentation, and thank you very much for your attention.
Thank you.